Discover deep bass, Miller and Kreisel sound. Well, this one was dropped off locally. Customer lives near me, so he just brought it in and dropped it off. Another Miller and Kreisel V-2B subwoofer. So let's go ahead and power the unit up, and I want to see if I get any light on that little LED right here. So here we go. Power on. And I see no light whatsoever. These were some nice units. Let's check the foam. It feels good. It may have been reconed at one time or another because I don't feel any rot whatsoever. Feels absolutely perfect. But let's go ahead and pull the board out of this thing and take a look at it and see what we find. Okay, so right off the bat, as you can see, I have an open fuse. So the first thing I want to do is get a schematic for the power output IC that lives underneath right here. Now on this unit, it is an STK086. So let me get the pin out on that chip and we'll do some resistance measurements. So here is the internal diagram of the chip. And so I'm interested in pins 6, 7, and 8. I want to make sure TR9 and TR10 are not bad. So I'm going to measure resistance from pin 6 to pin 7 and pin 8 to pin 7. Okay, so I am on the 600 ohm range. So I'm going to read from pin 6 to pin 7, and I see nothing. And pin 7 to pin 8, and I see nothing. And pin 6 to pin 7, I see nothing. So why would that fuse have blown? That is very interesting. Okay, well I went ahead and I powered the unit up. I put a new fuse in it, and I brought the AC voltage up slowly. And now check out what I see between pin 7 and pin 8. A dead short. 8.5 ohms. So pin 6 to pin 7 is okay. 4 mega ohms in discharging. But from pin 7 to pin 8, 8.6 ohms. So that tells me the STK086 power amplifier IC is indeed defective. Probably I want to go ahead and check all the caps in this unit before I go any further and just make sure we don't have any bad caps that might cause this failure. Okay, so here is the main filter cap board on this unit, and it uses some Nippon Chemicon 7200 microfarad 50 volt caps. And so I've got my ESR checker out here. It's just kind of hanging out of the back of the box, so it's kind of going to be kind of hard to hold it, but we'll go ahead and give it our best. So I want to make sure I see 0.0, and I do. And I see 0.1, 0.2. I'm not super happy with that. Once again, 0.0 shorted out together, and 0.2. So I'm going to recommend that the main filter caps get replaced as well. Okay, so here are a couple brand new 50 volt 10,000 microfarad caps, because it's very hard to find low value caps like 7200 microfarads anymore. So I had to go with 10,000. So first I'm just going to go ahead and verify my lead integrity is 0.0, and it is. And the cap is 0.0. The other cap 0.0. Okay, so I have the STK086 out of the unit. And so let's go ahead and check pin 6 to 7. No short. Pin 7 to 8. And once again, I'm seeing about 9 ohms. That definitely is the culprit. It's not a defect on the board. So let's go ahead and check the caps now and see how they check. Okay, so this board has 5 small capacitors on it, and I have them marked with red. That one's a 220, that one's a 220, and these 3 are 10s. So on a 220, I want to see about a half an ohm or less. And I see open on that one, and 0.9 on that one. These are 10s, probably 2 or 3 ohms would be perfectly fine. Open. Open, and 4 ohms. So it looks like we've definitely got some bad caps on this board. Well, at a minimum, it's going to need an STK power pack chip, the 2 220s at 50, and the 3 10s at 50 to be replaced to get this thing up and running. Plus that 5 amp fuse, already replaced it, so we know it's okay at this point. But I'll go ahead and get my customer an estimate, and we'll see if there is a part 2. Hopefully there is. Alright, so I have a brand new STK086. Of course, it's not an original Sanyo part, so I question its authenticity, but it's all there is out there. So let's go ahead and throw it in. We'll go ahead and replace all the small capacitors on the board, as well as the 2 large 7200 microfarad caps on the power supply board. Okay, all the old caps are out. Let's go ahead and install the new ones. And I'm going to go ahead and bend them down much like they had them from the factory. Okay, well here's a look at the capacitors that came out of the unit, and as you can see, both of the large 220 microfarad caps have been leaking. The little tins, kind of hard to tell because they're so much farther away and I have such a shallow depth of field. But anyhow, they all look pretty doggone good. Let me go ahead and focus in on those. But yeah, they seem to look pretty doggone good. I don't really see any problems with those. But let's go ahead and ESR them out of the circuit just to make sure. Okay, here we go. First, the 220s. And I'll verify my lead integrity. It should be pretty close to 0, and it is. First one, I get no reading whatsoever. And the second one, that one's not bad. I get 0.96 ohms, a little bit high for a 220. And now for the 10s, 4.5. That's pretty doggone good for a 10. I would actually consider that one to be just fine. And this one is totally open. And the last one, totally open. So it looks like we have one 220 that's good and one 10 that's good. All the rest were defective. I think I made the right choice in changing them all. Now let's go ahead and replace the 2 big 7200 microfarad caps. And once again, all I have is 10,000s to replace those with because you just can't find capacitors that small of a value anymore. Okay, so I've got my 10,000 microfarad caps here, and I'm going to go ahead and pull these little stands off the bottom because they are not going to be needed. I'm going to have to assume that this is correct, that this is the positive side on both of these capacitors. So it does only have printing on this side. It does not have a negative stripe like most do. But if I look at the bridge rectifier, might be kind of hard to see, but right there is the negative lead, and if I follow that lead on the board, It goes to this side of that capacitor, and that is the negative side. So I think we're going to be just fine. By the way, that date right there, 8707, is the manufacture date, 7th week of 1987. All right, there we go. Both negative leads are on this side. So negative, positive, negative, positive. Okay, now that the power supply is all done, let's go ahead and add some pretension to these Molex connectors like I usually do. Don't be afraid to like crush them in just a little bit because they will bounce back. All right, I think those will do. Let's go ahead and do the one female connector for this one male connector that lives on the main board also. There we go. That should be just fine. Okay, well, it's all back together, and it sounds terrible. I have my scope connected to the audio output lead from the amplifier, and this is the waveform that I'm seeing. And look at those dips that are in it. I think this thing is going into Class C, and I can show you the bias on the driver and the output transistors according to the schematic that they supplied. And I just think there's something wrong internally with this replacement STK chip. So let me turn this up a little bit to get a little bit more stabilization. Okay, so I realize it's got a heck of a hum. It's got a 100 hertz hum coming out of it right now. But look at that distortion. This thing looks absolutely terrible. Now, there's no way I can adjust the bias. Let's turn this back down. There's no way that I can adjust the bias on the output transistors. It's all preset in the IC. But let me show you what I found when I measured the voltages. So looking at the equivalent circuit, they say right here, if I measure from ground to pin 9, I should see effectively about 0.6 volt drop there and 0.6 volt drop there. So I should see about 1.2 volts on pin 9, and I should see about negative 1.2 volts over here on pin 5. So let's go ahead and measure those voltages, and I'll show you what I found. Okay, remember I said I should have about negative 1.2 volts on pin 5, and I have negative 1.262 volts on pin 5, and now I should have positive 1.2 volts on pin 9, and I have negative 0.043 volts. That's not right. The positive output transistors, the driver and output transistors, are not being biased on. So let's go ahead and just cover all our bases. Let's go ahead and look at pin 6. We should have our negative power supply. Should be about negative 30 something volts, negative 37 volts. And then pin 8, we should have our positive power supply. And it should be about positive 36 volts, 37 volts, and we do exactly. Now we'll look at the driver power supply voltages. Pin 4 should have about 33 or 34 volts, I believe. Pin 4, we have negative 33 volts. And pin 10 should have positive 33 volts. And we do exactly. So looking at the input pin for this IC chip, pin 1, we should have effectively 0 volts. And we have 0.013 volts. Absolutely perfect. Now pin 3 is the negative input, and we have the exact same thing. So there's no bias being applied to this IC other than like 20 or 30 millivolts. So I just think that we have a bad IC. Maybe not technically bad, but just manufactured bad. I've had problems with these replacement Chinese knockoff ICs lately, and I'm hoping that I can find a replacement IC for this unit. I did order an STK086G, which has a little bit different operational amplifier built into it. It has more of a differential circuit built in than the 086 has. So I'm going to go ahead and rip that package open and we'll give it a try. Incidentally, I did order 2 of these chips. They both perform absolutely the same. And I'll show you what I had to do even to be able to measure the voltage on pin 9, because this manufacturer of this STK086 did not even connect pin 9 internally as it shows in the schematic. So let me go ahead and get the STK086G. We'll take a quick look at the diagram, and then we'll slam this thing in there, and hopefully we have bias on pins 5 and pin 9 to get this thing up and running once again. Okay, so here is the pinout for the STK086G, and here is the replacement 086G IC that I have. So there's only a couple of minor differences in the application schematic right here. I do see a 1 microfarad cap in between pin 5 and pin 9 that does not exist on the regular STK086. In addition, I see between pins 4 and 5 a 100, I think it's 180 picofarad capacitor. That's the only difference that I can see between the two schematics. So as you can see, it has a little bit different differential amplifier in the preamp stage. So we'll see how that goes. But I'm going to go ahead and put it in. I will add a 1 microfarad capacitor between pin 5 and pin 9 on the back side of the circuit board, and we'll see if we get different results. Alright, so I didn't have any 180 picofarad capacitors, but I had some 330s. So I added a 330 between pins 4 and 5 and 9 and 10. And I wasn't happy with the bias. It was still driving the chip a little bit hard, so I pulled down the negative bias with a 1000 ohm resistor to ground right here. Then I added a 2000 picofarad capacitor across the input to ground right here. So I'm not 100% happy with the bias, but it is what it is. I've got to live with what I have. So the negative bias is negative 1.189 and the positive bias is 0.633 volts, which gives me a speaker output bias of 0.041 volts. Totally happy with that. No problem whatsoever. The thing is running ice cold right now, and so let me go ahead and give it some audio. This is 100 hertz of audio, sine wave audio going into it. And so I hear no crossover distortion. I took a look on the scope. It's a perfect pure sine wave at this point. Anyhow, that is it. I'm going to throw this thing back together, ship it back to my customer, and hopefully he has many more years of great Miller and Kreisel sound out of this unit. So just to recap, a 330 picofarad cap between pins 9 and 10, a 330 picofarad cap between pins 4 and 5, a 1 microfarad cap between pins 5 and 9, and a 2000 picofarad cap between pin 1 and ground, and a 1000 ohm pull down resistor between pin 5 and ground. So anyhow, that is it. The repair on the Miller and Kreisel V-2B subwoofer using the STK086G replacement IC, just because I found the 086s are not reliable parts. I certainly hope you enjoyed this video on the repair on the Miller and Kreisel V-2B subwoofer. Go ahead and leave me a question, a comment, a concern down below, good or bad. I try to respond to the comments when I have time. While you're down there, hit that subscribe button and like this video. It really does help my channel grow. You can follow me on social media, Facebook, Instagram, Twitter, at NorCal715. You can email me, NorCal715videos@gmail.com. That is the best way to contact me. I do have a full-time job and I do this in my spare time, so be patient if you do send me an email. Remember, with your help, we can try to keep these things out of the landfill, out of the recycle bin, and out of the e-waste facility. Everybody, thank you for making it to the end of this video. I really do appreciate it. Everyone have a great day. Once again, thank you so much for watching. Bye-bye. Okay, a little bonus footage. Here is the internals of the STK086, the non-G. So, to measure the voltage on pin 9, I actually had to add this jumper right here across these pads. They didn't have a jumper in there from the factory. So if I measure from pin 9 right here, I've got my ohm meter on the continuity and I show 1 ohm on it right there. So this jumper was never installed from the factory. I suspect the internals on this is not correct for what's on the schematic. I didn't have time to sit down and reverse engineer this, but I do see another pad right here that's missing a part of some type, maybe a resistor, I'm not sure. So if anybody wants to sit down and reverse engineer this, be my guest. Let me know what you come up with. I just don't have the time, unfortunately. So it appears that this is the driver, the positive driver, and then this would be the negative driver right here. And like I said, pin 9, never connected. I had to actually break the top open and add this jumper just so I could measure the voltage right here on pin 9 to determine that I had a really bad bias offset. Once again, if you want to reverse engineer this, be my guest. I gladly accept all comments on this chip. Anyhow, there is the top for it. You can see the date code B8C20. I'm always leery of these late date codes. I like to see the 4-digit date codes much better. And on top of it, this one on the back side has no printing whatsoever. I found that on the good STK chips, you will actually see some factory markings back here with a long list of nomenclature. I'm not even sure what it actually stands for or what it means. But anyhow, anybody want to take this on? Once again, be my guest. So just a little heads up, if you have a Miller & Kreisel V-2B, do not order parts from Consolidated Electronics. They supply the cheap Chinese knockoffs, and they will not work suitably in your Miller & Kreisel subwoofer. They will exhibit tremendous amounts of Class C distortion, where the outputs are not being biased on in a Class AB mode. Okay, so here is a close-up view of the old STK chip, the one that failed. So I thought I would go ahead and de-encapsulate it. So I know it's a very zoomed in view, but I want to show a very close-up of the output transistors and what I think might be the failure. If you look at this little line right there, I'm not sure if it's actually something on the chip. No, it's actually a crack. So I'm going to have to say that this is the transistor that failed. So let's go ahead and take a look around the rest of the STK chip. Maybe the Chinese can duplicate this one. That would be awesome if I could find an actual replacement chip that worked good. Okay, so there are the driver transistors and the pre-drivers. This is how STK chips used to be manufactured. Somebody added a 33 picofarad cap right there. And so there is the internal view of the original STK086 IC. If you want to reverse engineer this one, be my guest. I would love to see it. Anyhow, that's the whole chip view right there. And remember, I said that you can normally tell the good chips because they'll have a date code on the back of the IC. Anyhow, there is the cover off of this one, and the original date code right there, 6L16. I certainly hope you enjoyed the bonus material. Everybody, thanks for watching. Have a great day. Bye-bye.